We want to find the derivatives of the 6 trigonometric functions: sine of x, cosine of x, tangent of x, secant of x, cosecant of x, and cotangent of x. So we'll show you where the first 3 come from, and then we'll just memorize all 6. So if I have the sine of x, or I can think of it as this function sine of theta, I want to find the derivative. I'm going to come through and I'm going to try to figure out the slope at different places along this curve. So if you look back here where theta equals negative pi, and you tried to draw on the tangent line, you could zoom in on your calculator and find out that the slope is about negative 1. So I'm going to graph the point, negative pi, comma negative 1. I'm going to try to make a picture of the slope function, the derivative. At x equals negative pi over 2, my function flattens out for a second. So right there, the tangent is horizontal, the slope is 0. I'm going to graph negative pi over 2 comma 0. At 0, 0, if I tried to find the slope, I'd find the slope is equal to 1. So I'll graph 0 comma 1. At pi over 2, again, my function flattens out. I have a tangent whose slope is 0. And over here at pi, I have a slope of negative 1 again. If I connect these points with a smooth function, I get a function I hope you recognize. This is the cosine curve. So the derivative of sine of x is cosine of x. I could try the same thing for cosine. At x equals negative pi, the derivative of cosine, the slope of cosine, that's where it's flattened out, is 0. At negative pi over 2, I have a slope of positive 1. At 0, again, my curve flattens out. I have a slope of 0. Over here at pi over 2, I have a downward slope, so a slope of negative 1. And I flatten out again at pi. I could try to graph these, connect them with a smooth curve. And notice this is not the sine function. This is a sinusoid, but it's the sine function revolved around, or flipped around the x-axis. This is actually the graph of y equals the negative sine of x. So the derivative of cosine of x is the negative sine x, the opposite of sine of x. So we could figure out tangent now because we know that tangent of x is the sine of x divided by the cosine of x. So we can use what we know about the 2 derivatives we just learned and the quotient rule. So the derivative of tangent of x is the same as the derivative of sine of x divided by cosine of x. I'm going to use low d high minus high d low all over low squared. That's the quotient rule. So the lower function is cosine multiplied by the derivative of the upper function. The derivative of sine is cosine, minus the upper function, sine of x, minus the derivative of the lower down function, the function of the denominator, all over the function of the denominator squared. So I get cosine squared of x plus sine squared of x. I hope you recognize that as the Pythagorean identity from trigonometry. Cosine squared of x plus sine squared of x always adds up to 1. And I have my derivative. The derivative of the tangent of x is secant squared of x. Remember that 1 over cosine of x is secant. This notation, cosine squared of x, that means take the cosine of x, put it in parentheses, and square it. But we have this fancy notation that we can use. So secant squared of x. We can use the quotient rule actually now to find the derivatives of all the rest of the trigonometric functions. It's not required that you do that, so you'll just want to memorize these 6 derivatives of the 6 trigonometric functions. Write them into your notes paper now.